Good morning all, it's time for some new printed circuit boards. Let's open the box and see what we've got. Well, the first thing we've got is JLC PCB's new magnifying bookmark stroke ruler in passionate red. Actually, I'm going to try that. Oh, let's try it now actually for one of my let's have a closer look. Oh, it's not bad. I don't think it's quite as strong as my magnifier, but it's quite clear. Also, it would help if I took it out of its cellophane wrapper, wouldn't it? Let's try that. Yeah, a little bit of reflection on there, but not bad. So these printed circuit boards are the first ones that I've done in matte black. Yeah, let's have a closer look at those. Now I did these in matte black because, oh, these scissors aren't as good as my other ones. Because these are sort of related to optical stuff. Well, okay, they've got a few LEDs on there. So this is a rework of part of my LED Bargraph board, which is this board, which I've come to the conclusion was really too cram-packed. And as a result, there were various things that didn't quite work about it. So this is half of a replacement. This is going to be where the LEDs sit on the back of the board, and on the other side we've only got the LM3915 and a few resistors and 4 connection points, because let's come in a little bit closer. On this board I need to connect 5 volts, 12 volts, 0 volts, and the signal going into the LM3915. So I'm going to put LEDs onto this. Now, of course, I've got my new dim green LEDs. I've got red and yellow from the LM3915 kit packs. So I can assemble this board. So how matte is matte black? Well, it's certainly non-reflective. In fact, the only thing really reflecting here is the tinning on these pads. Well, I guess it's a tin lead coating on these pads. They're quite reflective, but the black itself isn't. The other thing I wanted to check on these is how translucent are they? In other words, can light get through them? And it can't, because you really can't see an outline of the tracks. And in fact, there are some quite fine tracks on this side connecting the LEDs up to the LM3915. Is it that side or that side? I can't remember. I can't see anything there, because if we look at the green PCB, light shines through and you can make out the tracks by using a flashlight, but you can't do that on a black PCB. So you do need to be mindful of that. If it's the sort of PCB you're going to be wanting to do lots of checking of by using light through, well, that won't work. So let's look at the problem with the Mark I PCB. Now this PCB sits there at sort of the opposite angle to all the other PCBs which come out from the front panel kind of horizontally, perpendicular. This one sits here. Now I put holes in the boards and I thought I could sort of rig something up with a couple of ring terminals soldered together or something like that. But this needs to be sat back so that the LEDs don't poke out of the front, but they sort of sit nice and flush with the front. But the other thing is you can see the green PCB behind here, and that's why I wanted to go to matte black, because I think that's going to look much nicer behind there. I can see a potential problem here. You probably can too, but we'll come back to that. So what I want to do with the matte black PCB is have it hanging back here. Now, one of the other problems with this is that it would have to be sat on little feet to space it away. I can't make it any bigger, because any taller and it'll foul the underside of the boards that are going to go up here. Any longer at the bottom, and you can see it's already pretty close to the bottom edge of the panel. And it can't be any wider, because there's 1/10 of an inch in there, and there's 1/10 of an inch between it and the board that sits here, which also sits in that orientation. So this was the maximum size I could go, and it's a bit cramped, and as a result things aren't quite right. If you remember, we've got a problem with the daughter board here for the RCA socket sitting over the chip, so I can't get the chip out. This capacitor is pushed over, even the power socket is slightly leaning over. The resistor down there is all at a squiffy angle because it doesn't really fit by the capacitor. This capacitor is leaning over because it doesn't fit next to the daughter board. It's all too tight. The board needs to be bigger. So the idea now is to go to a two-part board. This is one of the parts. The other part will be a green, oh, it might be a red actually, board that sits in the same orientation as the other boards on the back panel. Let me try and explain. So my new idea is to have this PCB sitting alongside this PCB, 1/10 of an inch spacing there, that's 2.54 millimeters. I can have some 2.5 millimeter nylon nuts and bolts running up inside there to hold these two boards together. Now remember, there's another board sitting over here, so this one will be sandwiched between the two, and with those nylon nuts and bolts it gives the ability for this board to slide forwards and backwards so that I can set the position of the LEDs relative to the front panel. Then this board will sit flat against the front panel, and so the two make up an angle like that. And in fact, you can see on this board, that's the LED side. There are a couple of connectors here. It goes that way around, I think. A couple of connectors here. So the idea is to have right angle DuPont pins sitting in there, header pins, and they will slot into holes which will be on this board. It doesn't actually have any because this is not the final board. I haven't actually drawn it up yet. But it'll be that sort of arrangement, and you can slide it forwards and backwards that way. And there's a little bit of height adjustment this way by having these DuPont right angle pins not soldered into this board. It moves up and down. Let me get that into actually the right position. It's kind of there. So yeah, you can see that the DuPont pins can slide, this can slide a little bit up and down. Now I don't quite know how I'm going to position it, probably with blue tack on this front panel. And then once it's fixed onto the green board, which might be a red board, I'll explain why in a minute, then the whole assembly can be slid backwards and forwards to get the positioning relative to the front panel. I hope that makes sense. Now just a quick word about colour of these boards. What I'm thinking of doing is having Rev 1 boards in green, and then if a board goes to Rev 2, and this one has to go to Rev 2, you will probably remember, if I come down a bit, the crossed over pins on the ICs on this board, because I got the pins the wrong way around. This is quite a nice magnifying glass because it's kind of widescreen. I can see myself using this. It's not quite as powerful as my other one, but yeah, not bad. So that needs to go to Rev 2, and I thought, well, what colour sequence goes green and then another colour and then another colour? There's RGB, red, green, blue, but G starting with a green. Oh, and then it hit me. So the WS2812, it's got absolutely nothing to do with my LED bar graph, but it's got red, green and blue LEDs. But I don't know whether you remember this, but the sequence you send the data is actually green, red, blue. So I'm going to sequence my revision PCBs in NeoPixel order. Yeah, so the NeoPixel bit of silliness gives me the perfect justification for having Rev 1 boards in green, Rev 2 boards in red, and Rev 3 in blue. So let's start assembling the LED board on very nice matte black printed circuit board. Now last time there was a bit of an issue with these LEDs being soldered flush to the board, because on a double-sided board, of course, you've got a solder pad on both sides. So the underside of this LED was sat right hard up against a solder pad. So when I tried to twist them, because they all obviously are slightly out of alignment, they were cracking, and that's probably the bottom part of the plastic cracking. So I want to lift these LEDs slightly off the board, and I'm thinking of doing that with a cable tie. Actually, I'm having second thoughts about that. If I put a cable tie under the LEDs on this side and then solder them, the cable tie is going to melt. That might mean that I have great difficulty pulling that cable tie out. Yes, because the cable tie is going to look not very good against the matte black. So on second thoughts, I might use a cocktail stick. Let's try that. So the first thing I need is green LEDs. Now the high brightness ones were a major issue. These are high brightness and they just swamped the red and the yellow. But then I bought some which I discovered were the old gallium arsenide dim type. So it's the dim ones I want. 7 of the dim green LEDs. Now that goes on the LED side. So LED 1 to LED 10. LED 10 will be red, red, yellow. So green starts here. I've got to work out the anode cathode thing. So long leg is pause. So that's got to be the anode. Current goes through down to short leg, which is the cathode. So the anode has to be the most positive. So the 5-volt supply runs all the way down there. So it must go that way around. Let's just check that it's the same on this board in terms of looking at the anvil or the cup part. Yes, that looks the same. Okay, I can solder that in, but not until I've raised that slightly off the board by putting a cocktail stick, which just fits between the legs. Lovely. So let's get all the green ones in, and then I'll try and find the red and yellow ones. Yes, that cocktail stick, yeah, I can withdraw that, that's fine. And that will just char, that won't melt, so it won't weld itself to the LED legs or the PCB or anything like that. Yeah, that slides in and out. I should be able to withdraw that. Let's find some red and yellow. Red and yellow LEDs, I'm going to steal out of one of these LM3915 kits, because they've got the red and yellow LEDs. There's the yellow, only need one of those, and then I need 2 reds. So the yellow goes in there, and then LEDs 9 and 10 are the reds. Wow, these have got really long legs. These old ones, I think they shorten the legs these days to save money, I guess. So now the next thing is to put another board on top to make a sandwich, screw them together. I've got some screws for that, and then I can get soldering. So I want to sandwich those together like so. Put my M2 screws either way. I suppose it doesn't matter, it can go that way. They're not a very good fit in there, but they should just provide enough adhesion to hold this thing together while I screw it. If they don't provide any adhesion, I could put something on the end of there, see if I can find something. Slight problem I've got here is that the red and yellow LEDs are slightly taller than the green LEDs, so maybe I'll put a strip of tape along there just to match the heights. Actually, they're not bad. If I just get soldering, these screws don't stay in very well because they're a bit of a loose fit. But if I just get soldering that, I can probably then just bend everything into position afterwards. So my LEDs are sandwiched in there with the cocktail stick. They do line up pretty well. I'm using these little rings as nuts for the screws to hold the whole sandwich together. I think it's all pretty well in alignment. Let's get soldering. I think I might solder one side of all the LEDs first because I wasn't entirely sure that they were all in alignment. So I'm just going to put I think this is the 5-volt line, which puts 5 volts onto all the LED. Oh, anodes it would be, wouldn't it? That's interesting. Something's happening with the matte coating. Don't know whether it's melting or whether it's just the flux showing up shiny against the matte surface. Yeah, I think it's the flux actually. You've got this very matte surface, and then the flux, of course, is creating a glossy effect on top of it. Let's take a closer look at that actually. So yeah, you can see that the flux creates gloss where there is otherwise matte. I'm just going to try my other magnifying glass for a minute, because I might have to go back to the oh, it's much closer, isn't it? Yeah, so you can see there that we got shiny flux residue on a matte PCB. So these are going to need a fair bit of cleaning, aren't they? So let's now unscrew my clamps, which are holding these two boards together. And, oh, I should easily be able to withdraw the cocktail stick. Oh, I say that, pliers needed, because only one side of the LEDs is attached. Oh yes, that's quite good. They all stand off by a nice similar amount. So I can now tweak these precisely into place and then finish soldering them. I'm not sure there's much tweaking needed actually. They're quite good. Yeah, it's the most important thing here is that the side-on alignment is nice and accurate, because that's the thing I'm not going to be able to change. I will be able to twist them and I'll be able to bend them up and down, but I won't be able to bend them side to side because of the two legs. But it's pretty good. I'm not sure that I need to do anything. Maybe that yellow one, just nudge it over ever so slightly. And I remember now, I think it was Sion, the Unexpected Maker. Go and watch the Unexpected Maker. I watch him a lot, particularly his live streams. He warned me that flux residue on the matte surface is difficult to clean, so I had been warned. But yeah, I think those are ready to solder. They look pretty good. Maybe those reds just need pushing over ever so slightly. Time to solder the other leg. Oh no, which one's this? This is the one that pulls low. So this is the current sink. This is the cathode. The anode will be the current source, won't it? Get some solder on there. And then I'll do the final alignment of these. The twist alignment and the sort of proximity alignment. Now, I was saying earlier that I thought there might be an issue with what I've done on this board, and I think that is going to be that these through holes are for the LM3915. The LM3915 I've had to move right down to the bottom of the board to enable me to put these two link pins. These are going to be for right angle DuPont headers, so that this thing can sit down on top of its horizontal board. But those 18, I think it is, pins are going to reflect light. Now, if I could have moved those out like I did with these resistors and these connectors, it's possible that you wouldn't have seen them through the hole. But then the LM3915 is a 300mm pitch chip. So does that require yet another daughter board on the back of here? I hope not, because then this will be a 3-board module. It's already a 2-board module. A board to sit alongside the other boards on the back panel. And of course this matte black board to provide the required optical effect of LEDs lit up, but the board not particularly showing itself off, which is what the matte black is all about. So now, because the LEDs are all slightly stood off the board by the diameter of a cocktail stick, I can do my twist alignment. There isn't a lot to do. I think that one needs to twist that way ever so slightly, and they won't make that awful cracking noise that we had last time. Okay, let's get the LM3915 on there. I've also put this 10k resistor on. Now this 10k is actually directly in parallel with the first LED, because the datasheet does say that there is a residual current into LED 1 even when it's off, because last time with the high brightness LEDs the bottom one stayed on in dot mode, I think it was, and the datasheet actually says 10k resistor across LED 1 is a fix for that. But they also said that it probably won't be a problem with inefficient LEDs, and these are the dim green ones, so it may not be necessary. So I've put the 10k position on there, but I won't solder the resistor on unless it's actually needed. LED legs always seem to be steel. Yeah, these are certainly steel. I'm not sure I want to mix those with my normal cut-offs because they're different. Let's prepare some suitable socketry for the LM3915. It's a 4 plus a 5 makes a 9 pin. Ooh, what happened there? That's okay. A 4 plus a 5. Those are my 9 pin arrays. The chip is in this kit, this LM3915 kit. Might as well use that. There is a socket in here, but it's one of those nasty leaf ones. I don't like those. I was just thinking, it's a pretty horrible thought, but if I leave these pins on the chip splayed out, and then I put sockets on here, and then sockets on there, and sockets on there, could I have this come out sufficiently far that I could have put these 2 rows of pins further out so they wouldn't be visible through the front panel? It is a horrible thought, isn't it? Now, because I haven't yet designed the op-amp board, so it's just the op-amp circuitry that was on this board, I think what I'm going to have to do is run some wires from my matte black board onto here, power it all up, put some audio in, and see that it works like that. So in fact, that op-amp will be driving both of these LM3915s, but that should be all right because I think they've got a fairly high impedance signal input. Right, let's solder these pins for the LM3915 chip. I'll do all this side first, and then I'll flip it around and do the other side. And because the LEDs are stood off the board slightly, it's actually quite easy to solder these pins in close proximity to the LEDs without melting them. Oh, I think I might have just touched one there, but very briefly. Good, that's that chip pretty much done. What else do I need? 150 ohm, 680 ohm, 1 microfarad cap. Again, I haven't put the plus on there, so I have to be careful I get that the right way around. P5 down there is to select dot and bar mode, and P4 and P3 are for these right angle DuPont. So I'll put those in next so that you can see how this works. There are my right angled pins, and the idea is that this would slip into this gap. It's not really big enough, so I've been experimenting with tipping it over at an angle to get these 2 in, and then trying to get those 2 in. I just haven't left quite enough clearance. I think I can do it if I just slightly snip back these inner 2. Let's try that. I don't want to take them back much, because then that limits my movement. Oh, they're quite difficult to snip. I'll do that now. So imagine that this is the PCB with the aligning holes for these pins. I can get those 2 in. Oh yes, look at that. With a bit of dexterity, I can get that to go in. So this is my horizontally mounted board, and the vertically mounted LED board, and once that's soldered, that'll be nice and rigid, just hangs off it like that. And then height adjustment on the front panel is afforded by sliding the pins up and down on the op-amp board, but of course once you've soldered that, then that adjustment no longer exists, so you've got to do that with some care. Last components are the 150 ohm and the 680 ohm, which go there. They set the what do they set? They set the level or the gain of the stage in here, which drives the LEDs. So let's put those in. Just wanted to try this thing to see if it can be done with the chip in place. So you start off tipping it this way, put it on, tip it that way. Oh yes, it works. Just. Okay, that's done. Big tidy up, and then I'm going to have to rig up some audio, some power, and some link wires between this board and this board so that I can feed audio into both, and we can see if they work. So here we are with a 5-volt power supply, a 12012 converter plus the 5 volts because the 5 volts drives the LEDs, signal coming in, signal also going to my speaker which has a coat over it because it's so loud that I've had to shut it up. Let's play some copyright free music. And you can see the overwhelming brightness of the green LEDs there. Now this new one, which I've connected a couple of these connectors to, these are actually in the kit, the LM3915 kit. This should have the dimmer LEDs, so they should all be a bit better matched. I'm going to have to solder these 4 wires onto here to pick off the signal from the op amp. Let's do that next. Right, I think that line there is 5 volts, but again I've got this problem where I can't shine a light through the board, so it's very difficult to follow tracks and find grounding points. I think I'm actually going to have to run up my Easy EDA software and trace it on the screen because I just can't do it on this board. So it seems that P4 red goes to 5 volts, so I'm just going to solder that on there. That's 5 volts. I can't see anywhere else I can get to 5 volts very easily other than actually on the connector. So that's that one. Let's do the other 3. Right, it's all connected up. I think I've got these connections in the right place. So let's run some music. Arms dealer. Power it on, and there's a problem, and it's also stopping this one working. If I take this cut plug out, this one works fine. If I take this plug out, this one works fine, but the new one doesn't work, and it just seems to pull it down. Also, that bottom LED is on. I'm not entirely sure why yet. Well, it's all fixed, but I made a bit of a mistake on the printed circuit board. Here's a clue. I had to scrape it away to even find it because it was hard to find because of the matte black coating. But let's see it working. Here's arms dealer. And it works fine. I'm just going to use this cloth to cover this one up because it's very distracting. So that's working. This LED had gone a nasty shade of orange, but amazingly it's recovered and it's fine. You can see there's a little wire mod there and a bit of scraping there, but essentially that works. So it's using the op amp on the other board, sending signal through one of these. They're 12 volt, 5 volt, 0 volt and signal, and that's working fine. And I can have it in dot mode, which is that, or I can have it in bar mode, which is that. So I'm going to end the video here because I think it's got quite long. I'm going to call it a success, but the design of this board had a major flaw in it, and I'll have to come back to that in another video, but for the moment, cheerio.